All right, so it says that John is driving to his office to attend a meeting in the first 10 minutes. He covers a distance of 1 mile every minute. Then he stops at a local restaurant for 15 minutes to have breakfast. And after that, he covers a distance of 0.5 miles every minute for the next 10 minutes. The first thing I want to recognize is that he's traveling for 10 minutes, right? Then he has breakfast for 15 minutes. And then he travels for 10 more minutes, and then he gets to his office. So he's on the road 10 plus 15 plus 10 minutes. So he's on the road for a total of 35 minutes. Okay. So that's important. So in the first 10 minutes, he goes, this is critical. Let's unpack this. In the first 10 minutes, he covers a distance of 1 mile every minute. If he goes 1 mile every minute for 10 minutes, how many miles does he travel total? 1 mile a minute, and he travels for 10 minutes. How many miles does he travel total? 10, right? So after 10 minutes, he will have traveled, right? Because it's minutes and miles. So he would have traveled for 10 minutes, a total of 10 miles. So he starts here and he travels this far. Then it says the next 15 minutes, he sits and has breakfast at a restaurant. Is he traveling when he's eating breakfast? No. How long is he traveling, or how long is he having breakfast? 15 minutes. So he doesn't move his distance, but he sits there for 5, 10, 15 minutes, right? So now he's been gone for 25 minutes total. 10 plus 15 is 25, correct? So now here's the interesting thing. The last part of this piece is that he travels a half a mile every minute for the next 10 minutes. So if you want to know the distance somebody travels, the distance somebody travels is the rate times the time. Well, he's traveling 0.5, right? Miles per every minute times 10 minutes. What's half of 5? Or not half of 5. What's half of 10? I said the answer. What's half of 10? 5. So in the next 10 minutes, he travels a total of 5 miles. So if he's at, remember, these are the miles. If he's at 10 miles right here, then that means his minutes will be 35, right? And his total distance will be 5 more miles than 10. So he would be at 15 miles, correct? So then I'm going to go over to 35 and come up 15. And that's it. That's all we do. So what I've done is I've taken a real world scenario and I've plotted the time versus the distance. So now I have a graphical representation of what John really did. Now, would you think that the graph would look this way? It's a little counterintuitive at first. But eventually, the more you look at graphs like this, you'll see, okay, from here to here, when the slope is 0, he wasn't moving at all. Here he was going faster because the slope was steeper. And here he was traveling slower because the slope is not as steep. Does that make sense? Maybe not at first.